Hello, everybody. My name is Neel Vasavada, and I'd like to thank all of you, especially Michelle from Muse, for joining us today to talk about sustainable energy in live events. So let's start with who I am and how did I get involved with sustainable energy. So this is me back in 1994 at the University of Wisconsin when I started working with hybrid and hybrid electric vehicles um, as part of a student competition involving the US Department of Energy. From there, I went to work in data recording, data acquisition systems, and power control systems from motorsports, and then with prototype vehicle manufacturers, including Tesla, Zero electric motorcycles, and then I also did some stuff with the US Department of Energy. Um, Live events came into my life about 2010 when I started working with EPS America, providing barricade and flooring to live events. And as I got to know that business, and then the pandemic happened, I realized that there's a lot of opportunity for sustainable energy in live events, the way we do things. So, there I am in my racing days, driving forklifts, and then finally the last piece of the puzzle. Well, I've been to Burning Man a bunch of times, and over there, sustainability is not just a something that people talk about. It's something that you kind of need because resources are very scarce. So you put that all together, and in this little shed in my backyard, we created Overdrive Energy Solutions. So let's talk about different sustainable energy sources and what they are. Before I get into um, electrification or solar or anything like that, I want to talk about two big things that we hear a lot about. One is HVO fuel, which is derived from hydrogenated vegetable oil, and it's a diesel substitute. And the other is hydrogen. A lot of talk in the music space about sustainable energy sources like this, and they are potentially great power sources for certain applications, but we have to remember a few things. First of all, if we're running an engine, well, the best engines in the world are 35 to 40% of what's called thermodynamically efficient. In other words, the energy that's in that HVO diesel, only about 35% of it actually is useful. So you got to make a whole lot more in order to get an effect out of it, right? So you're going to need to have sustainable practices from the beginning, sustainable planting, sustainable farming, all of that. Until all of that can be sustainable, and again, we have to make an excess of it, that's not a sustainable approach. Hydrogen production is expensive, and storage and transportation are big issues. We have a very good model of how we deal with hydrogen. We know that from compressed natural gas, which has been used as a vehicle fuel for a long time. At the end of the day, in order to really be sustainable, we need power from sun, wind, geothermal, even nuclear, but a naturally occurring power source. And that's what we're going to talk about today is electrification. So solar panels can turn about 20% of the sun's energy that hits them into electricity. And that's only, about 200 watts per square meter. So if you want to run just what's in a single 110 volt outlet, you need a 9-foot by 9-foot solar array that's operating in perfect conditions. However, and this is the big innovation here, we can store this energy now. We can store it for later use. So we can collect all day, all week, however long we are waiting for our event, So when we have time and space, the sun is our friend, And well, one thing about our industry is it's ideal for this kind of application. Okay. Before I go into that, though, I talked about time and space and storing energy. I want to address a little misinformation that's still out there about batteries. They've always let us down, right? And as you see here, laptops, phones, we've thrown them away over and over again. But this has largely been solved. Lithium iron phosphate batteries, which are used in current standard range Teslas. Ford just announced that they're building a large North American plant to build these. It's really game changer. In our industry, they last 15 to 20 years. And even at the end of that, they're 100% recyclable. One really interesting thing is there's no toxic materials, and there's none of the fire and explosion risks that you've heard of with previous batteries. So they're very safe. One really cool thing is they're scalable. Whereas you can't really take a large 100 kVA diesel generator and break it into 10 little generators and spread them around and expect to be efficient. You can do that with batteries. One battery is a fraction of the total. In other words, if we have a 100 kVA battery array, 1/10 of that would be just as efficient at 10 kVA. So the real challenge here with batteries is managing transport and charging, and I'll talk about that as well. So let's go back to now live events. Why are we talking about live events? What's so great about them? Well, first of all, the layouts are perfect, right? We have roofs, but we need shade structure, and we tend to operate in the sunshine. So we have a great natural place for solar collection. And the other thing is that we know when we're using the power, right? So we can plan accordingly. We don't need these generators that make power on demand. We know what we can collect with the sun, and we know when we're going to need it. Finally, our draws are well known. Unlike a lot of other industries, we know what the equipment on our stage is. Everything from performance to lights. We know what food and beverage. We know what power draws are needed. So with these three things in mind, all of a sudden, collecting that energy, storing it to use for later, makes a lot of sense in our industry. So to give you an idea, I want to run a little case study here. This is an event that happened right before New Year's in Southern California in the Mojave Desert called Coalesce 2002. This here is a little list of the equipment. Now, it's a small DJ stage. I do want to keep in mind that the gear that we used for this was about 1/4 utilized as far as its power output. So when you look at that list there, multiply it by 4, and everything I'm talking about here, we're well within our capabilities, right? So here's some data from that event, and there are a couple important takeaways from here. The red line shows how much energy total was used, but the blue line shows the power per every averaged over, I think it was 20 minutes. And you can see it varies quite a bit depending on the DJ and the style of music and everything like that. You know, at its highest, we were almost twice as much power consumption as at its lowest. But the way batteries work are very different than generators. Because we can store the energy, it's only the average that matters. And it turns out that the averages can be, fairly low because there's peaks and there's valleys. So in this situation, we were able to run 15 hours completely sustainable on electricity alone. Now, you look at this from a generator point of view, you wouldn't think it's possible because a generator has to be sized for that peak load, which here you can see was 1.38 kilowatts, right? But since the batteries to charge are about a more reasonable average load, we can now run events for long periods of time on stored battery electricity. One aside I want to point out too is the voltages. You see over there on the right side, we have now been told by several sound engineers that there is a audible difference in the quality of the sound that comes from these sustainable energy battery generator systems from electrification in a battery sense. So much so that, in fact, next month we have a test with a Grammy-winning guitarist about this. So, what's interesting when you use technologies is you find other benefits oftentimes, and here's one of them. Talk about another event we did with Long Beach Living, and this is also going to talk about some of the benefits that come outside of just the power. So you see that site there. There's a stage at one end. Okay, it's about 3 acres. It's a lot. It was a food and beverage festival. On the left, there were some bouncy houses. At the bottom, there was food, and there were a bunch of food vendors. And there was a generator down for those food vendors because they had very high energy consuming water heating and electric air fryers and things like that. But you know what there wasn't on this site? There isn't any distro. There's no cables, none of it, because all of the stuff in the middle there, all the retail booths, all the bars, the eating areas, everything was powered by battery systems that were placed directly where they were needed. So in this case, we didn't need, there was a big sustainability thing is the fact that we didn't have to transport that gear, we didn't have to use the gear, and from a cost perspective, not running all of the cable trays and cords, and you can imagine all the power distro that would have been needed in that area, saved enough money to pay for the sustainability part of it entirely. Another thing we did was hybridize the generator there. What we did was we used our battery systems to actually run those generators at a higher load, because it turns out that diesel generators are actually more efficient at higher loads than lower loads. But because of that spike thing that I showed in the last chart, you have to size them for really large loads. So even though there was a generator on site, we actually made that generator more efficient by using it to charge batteries, which we then used in this case for the inflatables. So let me explain a little more about how we can use electrification to get sustainability at our events. And we do this by reimagining how we do power, okay? Instead of having a single large generator that is then connected to your site via a lot of transformers and distribution equipment and cables that then you have to cover with cable ramps so that your audience doesn't trip over it, et cetera, et cetera, et cetera. We can put these battery power stations where the power is needed. Imagine, if you could put your generator directly in front of house, how much simpler that makes things, right? Well, now the battery generators can take solar energy, they can take power from the grid, and they can take power from generators, and they can also start and stop the generators. And then the control systems inside of the generators can combine these different energy sources to get you the most sustainable result, or the most resilient result that's backed up, or the most cost-effective result. So now sustainability isn't just an on or off thing. We can be 100% solar powered and sustainable if the conditions allow. We can reduce our dependence on grid power, or we can even use grid power that might not be all the power we need, because the batteries can supplement them, or we can even use generators, again, in more efficient ways. So all of this stuff is also recorded and tracked by data, so we can tell our audiences, we can tell our clients, we can tell our artists that this event was X amount sustainable. It saved this much fuel. It reduced these many emissions. So by doing these sorts of sustainable electrification hybrid systems, where we place the units where they make the most sense, not where they need to be for sound or for emissions, we can lower costs, make our sites safer, make them more resilient, backed up, and make them more sustainable. So let me give you a few examples of how we make sustainability simple, because frankly, in order to work in live events, things need to be simple. They need to be able to get in and get out and be reliable. So let me start with the top left picture here. What we have there are solar mats. The technology exists right now. It's also in the picture below that, where we have flexible, glassless. You can walk on them, you can drive on them. Solar panels that are on tarps. Simple. You can deploy them quickly at a site and generate power, and they're durable, so they can be folded up and taken to the next event and next event and the next event. Okay. The middle picture, the top picture over there, is from a film shoot. Now, here's another example of where sustainability can give a practical benefit. Those two generators ran 3 Arai Sky panels and a 1K Parcan at a shoot for about 9 hours. There was no what they call putt-putt generator required that would have, in this case, been down the street with long extension cords so that the sound wasn't intrusive when they were recording and things like that. Here, their main impetus for using the battery technology was so that they could have a quiet, clean set, so they didn't have to take parking in the neighborhood and things like that. and also happen to be sustainable. The bottom there, equipment transport. So one of the things I said earlier is, one of the big challenges here are charging and transport. I talked about some of the charging things, when we can do hybrid systems on site. As far as transport goes, one of the things for transport is the fact that scalability I talked about. When you can take 100 kilowatt kilovolt amp system and drop it in, break it into 10 systems, it's much easier to transport in existing vehicles, not need more truck space, etc. And the other thing that we've done is built solar charging vehicles where the battery generators are actually transported in the vehicle with solar in it so that it's ready to go whenever you unload it. Or we've done it the opposite way, where we've had battery systems like speakers and timers and lighting that are rechargeable that are also transported in a van that has solar panels and has battery generator systems inside. So it's collecting solar energy all day, and then in the evening, equipment, when the work is done, is loaded into it, and this van is now the charging station. So here is a way that we have mitigated the transport requirements by combining the charging and the transport and the electric and the storage. The same thing goes for mobile stages. Stage line in particular are perfect for this because they have a solid roof. So now, without adding any transport requirements, you can add solar, batteries, etc., to a stage like this and make a completely sustainable off-grid stage. So again, in all these examples, we are getting, we're actually simplifying our job by making things more sustainable. So those are just some of the things that we can do with sustainable energy and electrification to make our sites, again, more sustainable, resilient, safer, and even more cost effective. Thank you again for all your time. Thanks to Muse for having us here. And we look forward to speaking with many more people in the future about sustainability and live events. Thank you.